Greetings. Welcome to our 31st episode of the FGI podcast series. My name is Tim Stark, and I'm a professor of civil engineering at the University of Illinois at Urbana-Champaign.
And hello, everyone. My name is Jen Miller, and I'm the coordinator of the Fabricated Geomembrane Institute, or the FGI.
On today's episode, we are going to focus on our June 29th, 2021 webinar titled GCLs and Fabricated Geomembranes. I'd like to quickly reintroduce our speaker, Chris Athanassopoulos. Chris is a tenured professor at Harper College, north of Chicago. Before joining the faculty of Harper College, Chris was a practicing civil/environmental engineer for over 16 years. During most of this time, Chris was the technical services manager for Setco, which is a major producer of geosynthetic clay liners, i.e. GCLs. At Setco, Chris was involved with design, testing, R&D, manufacturing, and installation of GCLs. So we welcome Chris back to answer questions from his webinar of June 29th. So, Chris, we have two sets of questions. One set are questions that we did not have time to answer during the live presentation, and then we received many questions after your webinar in the follow-up survey. So, Chris, thanks for joining us.
Thank you. Good to be here.
Okay, here's the first question from the live presentation. How does the polymer improve the bentonite effectiveness? Is it physical, chemical, or both?
It's actually a complicated mechanism, and there are both physical and chemical factors at work to improve the overall performance.
Great. Second question, Chris. Why would anyone design a liner system with the drainage composite beneath the GCL?
So a few scenarios come to mind, I suppose. I mean, one would be in a landfill cover system where you could use a drainage geocomposite as a gas collection layer underneath the barrier. Another alternative is one that we touched on during the presentation. If you have a double-lined landfill bottom liner system, you could use that drainage geocomposite as the leak detection layer underneath the primary composite liner. And I suppose another setting that I've seen is if you're working at a site with a high water table, you can use a drainage geocomposite as sort of an underdrain.
Right. Next question, showing the GCL with the geomembrane exposed, does the geomembrane provide adequate confining pressure on the GCL if exposed, or should it be covered?
Yeah, I would say the geomembrane alone does not provide enough confining stress on top of the GCL, so I would recommend a minimum of 1 foot of soil cover.
Great. Next question, GCL without a geomembrane is being spread out for a final cover system where confining pressure is an issue. Is it also used in leachate surfaced impoundments that have very little confining pressure when they have only about a foot of leachate on top of the geomembrane?
So I would say, you know, during the webinar, the issues that we referenced that were related to GCLs left under an exposed geomembrane, that had no soil cover at all for an extended period of time, months or years. So in those situations, that exposed geomembrane can undergo huge temperature changes, which can cause problems for the materials underneath it. But it sounds like in the applications that are being described in this question, the liner won't be exposed in the same way. It sounds like there's going to be some minimal amount of soil cover, and that is sufficient. Whether it's a foot or two, it should be sufficient soil cover.
Okay, thanks, Chris. The next question is, how does freeze-thaw impact GCL behavior?
So we've seen that GCLs actually hold up very well to freeze-thaw cycling. I'm reminded of a study from the early 2000s from the Idaho National Engineering Laboratory, INEL. They had GCL specimens, exposed them to up to 150 freeze-thaw cycles, and they saw no appreciable change in hydraulic conductivity.
Great, thanks, Chris. Next question, what is the best way to analyze diffusion of organics through a GCL versus what organics would diffuse through a standard compacted soil liner?
So this is a good question. We often focus on contaminant transport by advection, in other words, the flow of water carrying contaminants through a liner system. But there is also the potential for contaminant transport by diffusion, and that's driven by a concentration gradient in the liner system. And so to model that diffusion, there are some analytical models in the literature that kind you can program into a spreadsheet. But to be honest, those are limited. So usually you need something more sophisticated, like a commercially available numerical model to perform that type of calculation. I do want to say that in either case, whether using analytical or the numerical model, if you compare a GCL by itself to a 2-foot thick compacted clay liner by itself, you're going to predict there's going to be much less diffusion through the compacted clay simply because it's so much thicker, right? The concentration gradient depends strongly on the thickness. But that's a little bit misleading because in reality, you're always going to have some layer of subgrade soil underneath the liner system to provide a firm base for construction activities. So I would say if you run the model with that layer underneath as an attenuation layer, some foundation soil doesn't need to meet any strict permeability requirements, you'd find that the predicted diffusion becomes much more comparable between the two.
Right. Next question, is it possible to use cast in situ concrete on a GCL as the protective layer?
So this is actually commonly done in different market in below grade building waterproofing applications. In those settings, you'll see the GCL placed first, and then the concrete slab is poured directly on top of it. And what happens is that forms a pretty strong bond between the GCL and the concrete because the fibers from the geotextile become embedded in the concrete.
Right. Chris, is the shear strength versus peel strength data that you showed on granular, was it the data that you showed, was it based on granular or powdered GCLs?
So that data that we showed in the webinar was from one specific product. It was a needle punch reinforced double non-woven GCL that was produced with granular bentonite. But I will say, if all else is equal, I wouldn't expect different internal shear strengths for a GCL made with powdered versus granular bentonite. I mean, the difference is really gonna be a function of the manufacturing process, the needle punch density, and the geotextiles that are on either side of the bentonite.
All right, thanks, Chris. Next question. Do polymer amended bentonites result in a lower shear strength?
So this depends on the type of polymer and the loading. So the short answer is GCLs with polymer amended bentonite may or may not exhibit the same shear performance as a conventional GCL. So for that reason, I'd recommend shear testing of these products.
Right. Chris, some applications have a temperature gradient on the GCL/composite liner system, such as a heap leach pad. The viewer was wondering if there will be moisture migration over time due to the temperature gradient across the liner system, and would that affect the long-term performance of the GCL and composite liner system?
So another good question. I honestly don't have a definitive answer to this, as it is an area of ongoing study. I'm aware of studies both at Queen's University and Colorado State. They're investigating the effects of high temperatures on liner system components, both the geomembrane and the GCL. But I will say from the previous work that I've seen related to GCLs, and this has been some good work out of Queen's University, where they did both lab tests and numerical modeling to determine the potential for desiccation of the GCL. Their findings suggest that if the GCL is placed on a subgrade soil that has a high initial moisture content, then it's going to be less likely to desiccate or dry out, even if it's exposed to a large temperature gradient. But more work is needed in this regard.
Right. During the webinar presentation, you showed some data about polymer amended bentonite, and the viewer is asking, how long did it take to develop the amendments for the two figures with low hydraulic conductivity that you showed?
Oh, so that work was the better part of a decade of R&D.
Okay, do you have any experience of underwater installation of GCLs?
So I personally don't have direct experience with underwater installation, but I have heard, however, of successful case studies from Europe where GCLs were deployed underwater to line canals. And I would say in that application, two main things to consider. You should use a GCL that's needle punch reinforced. That way you can prevent excessive swelling of that bentonite layer. And then you should also try to cover that GCL with sand as soon as possible after deployment.
Thanks, Chris. Now I'd like to shift to the questions that we received after the webinar via the follow-up survey. And we have 7 of those. With polymer amended bentonites, do you still place regular bentonite in the overlaps between GCL panels?
So no, I wouldn't place regular bentonite in the overlap. I would recommend placing the same polymer amended bentonite, and that could be supplied in bulk, in bags, in the GCL overlaps.
And would you apply the same quantity? I think it's what, 1 pound per foot or 1 pound per something?
It's so what I've seen is a 1/4 pound per lineal foot, and I would recommend the same application rate.
Quarter pound per lineal foot. Great.
Yeah.
Next question. This viewer would like to know the reason behind laying bentonite in the overlap of 2 GCLs during installation, which we were just talking about.
Right. So the way that the GCL is deployed, it unrolls into these rectangular panels. And the adjacent panels aren't physically seen together like a geomembrane is. They're simply overlapped by 6 to 12 inches. So that overlap area could be a pathway for preferential flow for leakage. So that's why we recommend putting that supplemental bentonite there to kind of cut off that pathway.
Right. The next question has to do with the leakage formula, JP Giroux's leakage formula. A couple of questions. First, is the T and H in Giroux's equation the same thing or different, if you could define them? And how does the GCL get hydrated after being placed?
Okay, sure. So the lowercase t in the Giroux equation, that represents the thickness of the soil layer underneath the geomembrane. And you may see it either as T or T with an S subscript for soil. And then the H, that represents the height of water above the geomembrane. In other words, that's kind of the driving force for the flow. And moving on to the second part of your question, so I think I heard you say that how does a GCL get hydrated after being placed? So what we've seen is that GCLs usually become hydrated by pulling moisture from the underlying subgrade soil. And there have been multiple studies that have shown this. If you place a GCL over a subgrade soil that's compacted at optimum or wet of optimum, the moisture that's available in that soil will allow the GCL to become hydrated within a few months of placement.
Right. One last question, Chris. How do you determine a proper leachate for the GCL hydraulic conductivity test?
Another good question. So it depends on the site, right? If this is a new cell, or if this is an additional cell for a pre-existing site, there should be leachate data available for the adjacent cells, right? That would be the easy solution. But if it's a brand new site, perhaps in one of these emerging markets like CCPs, coal combustion products, or mining, then I think it's important to work with the site owner to get an idea of the chemistry of their process and their waste stream, and ideally get a representative sample for upfront testing.
Chris, the next question is, has scrim reinforcement of GCLs helped reduce or eliminate shrinkage or necking of GCLs?
So when this issue of GCL shrinkage and necking first came up, when it was first discovered underneath exposed geomembrane, the thinking was that yes, a scrim, or in other words, a woven geotextile component in the GCL would limit the potential for shrinkage. However, in what we've seen more recently, it's turned out to be more complex than that. So from the research, it seems like it's a combination of that scrim reinforcement and thermal locking. In other words, heat burnishing on one side of the GCL that helps prevent that shrinkage under an exposed geomembrane. I do want to say, though, that we should be careful to note that this shouldn't be seen as a license to leave a GCL under an exposed geomembrane indefinitely. All the standard geotextile encased products, whether or not they have scrim or whether or not they have thermal locking, they're still susceptible to bentonite erosion, the other issue we talked about in the webinar. So based on this, I feel like the most effective strategy to address both this shrinkage issue and the downslope bentonite erosion is timely placement of cover soil on top of the geomembrane.
Right. Chris, next question is, this viewer would like some ideas and your thoughts on simple QA tests that could be performed on polymer modified GCLs. Are they different than what would be used for a regular GCL, or the same?
So this is another really good question, and the answer is yes. Potentially, we would need to look at different tests. As it happens, ASTM has formed a work group to address these types of questions for polymer modified GCLs, but I don't know the status of any new standards at this time. So I would say until those standards are available, I think it's important to have a conversation with the GCL supplier to determine what short-term QA tests they're using with the polymer modified products. So on projects that I worked on a few years ago, we used something called LOI, which is the loss on ignition, and also a fan viscosity test to evaluate the polymer content in the finished GCL. And then similar tests were used for QA testing on the finished GCL.
Great. Chris, next question is, when reviewing proposals for liner systems, what are the questions that you ask yourself? For example, type of liner system, what will work well, etc.
So I would go back to those main design considerations we touched on in the webinar. You know, the three were hydraulic performance, chemical compatibility, and shear strength. And I would just drill into each of those three. And I'd also recommend working with the geosynthetic supplier. You know, they have engineers on staff who can help address your questions for your specific project, and they're really a good resource.
Right. Last question, Chris, and we touched on it earlier, is if there is, will there be moisture migration over time if a temperature gradient is present with a GCL?
So potentially yes, and this is still the area of ongoing study, but I would say based on the work that I've seen out of Queen's University, it depends strongly on the initial moisture content of the subgrade soil. So if there's a high initial moisture content in that subgrade soil, then it's less likely for that GCL to desiccate, even when exposed to the temperature gradient.
Great, Chris. That's all the questions we've received. So thanks for joining us again, Chris. If you have additional questions, Chris's contact information is on the last slide of his PDF, or it is cathanas@harpercollege.edu. Or you can email me at the FGI, fabricatedgeomembrane@gmail.com, or visit the FGI website at fabricatedgeomembrane.com. So Chris, thanks so much for joining us again and answering all of these webinar questions.
Thank you both.
Thanks, Chris.
Thanks, Chris.
See ya.